All right, look at these couple problems for test 3 review, worksheet of the day. So if we look at these, the first one we asked about was number 1, and this just looks like an equation we're trying to solve. Now the easiest way to do that is we'd like to get the bases to be equal. So we'd like the bases to be the same. Now, this doesn't always work, but this would be the first way I would try it. Like if, for example, in number 5, we're not going to be able to do this, we'll have to do it a different way. But if we get the bases to match, that makes it really easy. So if I look at my two bases, let's look at 27. I'm just looking at 27 because it's a little easier. I know 27 is 9 times 3, and I know 9 is 3 times 3, so 27 is 3 times 3 times 3. So it's 3 to the third. Now, that is very helpful because if I look at 1/9, I know that 9 is 3 to the second. I know 3 times 3 is 9. So if it's a fraction, we can just say 3 to the minus second is 1/9. So now we can replace these in this equation. So instead of this 27, I can write 3 to the third. And I just want to make sure I put the existing exponent in parentheses. So it would be 3 to the third times 3x. And then I can replace 1/9 with 3 to the minus second to the x plus 3. So if you do this and you make sure you put your exponents in parentheses, it's pretty straightforward from here, because since the bases are the same, that means the exponents have to be the same. So 3 times negative 3x has to be equal to negative 2 times x plus 3. And we just now have to solve this as a linear equation. So this is negative 9x. I'll distribute here. That gives me negative 2x minus 6. I'll go ahead and add 2x. Since it's just linear, we get all the x's on one side and then divide out. So negative 6 or 7x equals negative 6. And then I'll just divide by negative 7. So if you ever get an exponential equation, the first thing you'd want to try to do is make the bases match. If they do, great. If they don't, then we'll have to do it kind of how we'll do in number 5. So this last one is to graph a log function. So if you graph a log function, it's easier to, if you're doing it by hand, you can certainly use your graphing utility. I would just start with a basic log function, log base 2 of x. Because then we can start with 3 points on this graph. One thing I know, every basic log function has a vertical asymptote of x equals 0. And we can change that when we do our transformations. So we know that there are always 3 points on every log. There is the base point and 2, and when I mean base point, it's whatever base this is. So 2, 1 is always on there. 1, 0 is always on every log. And the other one that's going to be on there is negative 1. Oops, negative 1 is a y, but 1 over the base. So 1 over 2. So these are always going to be on every log. So if I want to write this more generically, this is b comma 1. This is 1, 0, and this is 1 over b, negative 1. Those are all true. So my transformations I see here, I have this 3 out front. So that's going to multiply all the y's by 3. And remember, this is a shift to the right, because everything in the parentheses goes backwards by 2. So I'm going to add 2 to all the x's. So I'm going to multiply all the y's by 3, and I'm going to add 2 to all my x's. So that's going to make my new vertical asymptote x equal 2. Because it was x equals 0, it's an x, so I'm adding 2 to it. So there's my new vertical asymptote. And then I just do the things to the points in my table. So I'll multiply all the y's by 3. So 3, 0, negative 3. And I'll add 2 to them all. So 4, 3, and if I add 2 to that, I get 2.5 or 5 halves, whatever you want to think of it as. And then I'll just plot my points. So I get 4, 3, which is there. I'll get 3, 0, which is here, and I'll get 2.5, negative 3, which is there. And then my log is going to look something like this. And that is my graph. Now again, you could certainly graph this on a graphing utility and kind of get some points. It doesn't always help you with the vertical asymptote, but it's a great way to check that you make sure you've done it correctly. So hopefully these are helpful. Obviously, if you have more questions, please let me know. So let's look at number 5 now, and then we'll go back to number 2, just because it's a little, it's very similar to the one we just did. Now the reason this one doesn't work, if I do 7, 7 is just 7 to the first, and 4 is just 2 times 2, which is 2 squared. So there's no way I get the same base here. So this is definitely probably the hardest kind of problem we're going to do in this section for this exam. So what I'm going to do is, if I can't get the bases to match, because again, I always want to try to do that first, then I will try to take the log of both sides. Doesn't matter which log. It could be natural log, it could be common log, whatever you want. So I'm going to take the log of both sides. Now why this will benefit me is now, since I have a log on both sides, I can take these exponents down. You can bring exponents up, but you can also bring them down. In this case, that's going to be our easier method. So 3x log 7 equals x plus 1 log 4. Now don't be afraid, because log 7 is just some number, and log 4 is just some number. So these are just numbers. They're nothing besides that. So we're going to distribute here. I'm going to rewrite the left side a little different. I'm going to write it as x times 3 log 7, because again, those are all just numbers. And when I distribute on the other side, I'll get x times log 4 plus 1 times log 4 is just log 4. Because again, they're just numbers. So now, believe it or not, this is just a linear equation where I have x's on both sides. So I'm going to move all the x's to one side. Now let's just write it out. So we'll get x times 3 log 7 minus x log 7 equals log 4. So now we both have this x here, so the easiest way to look at it, I could factor this x out. So if I take an x out, I get 3 log 7 minus log 7 equals log 4. So you can see why you like to get the bases to match, because this is a lot more work. So our final answer is, now we have x times something, we'll just divide it to both sides. So x is going to equal log 4 divided by 3 log 7 minus log 7. And that is a fine way to keep it. Actually, I made one mistake. This is supposed to be a 4. So this is a 4. So this is a 4. I just miscopied it. That looks better. So log 4 over 3 log 7 minus log 4. Again, very easy to make mistakes because there's a lot of logs and a lot of terms going on here.